This is a video on simplifying algebraic expressions, and I'm going to start off at the very basic level by just going over terminology. This is referred to as an expression because there is no equal sign. If we had something like 3x plus 5y minus 9 is equal to 18, that is referred to as an equation. The coefficients are posh words for something in front of. These could be letters or numbers. Now let's have a look at the first coefficient there, 3x. That means we've got x plus x plus x. And we've simplified that by saying 3x. For example, if you have 3 books, you don't refer to them as book, book, book. You say 3 books. And 3 is the coefficient there, and x is referred to as the variable. And a variable can take any value. For example, we could do 3 times 100, which is 300, or we could do 3 times 50, which is 150, or we could do 3 times 1,000, which is 3,000. And I hope you can see that x takes the value of 100 there, x takes the value of 50, and x takes the value of 1,000. Now the next thing is that if two things are next door to each other in algebra, if two things are adjacent, we say they are multiplied by each other. And AB is the same as doing BC. It's the same thing. Now let's go over some more terminology. So we've written down a basic algebraic expression. 3x plus 5y is equal to 9. And we've said that the 3 and the 5 are coefficients, the x and the y are variables, and the negative 9 is also a term, is referred to as the constant term. We can't simplify 3x plus 5y minus 9 because it's already in its simplest form. I've seen students do this, which you should never do. You cannot add 3 plus 5, which is 8, and then subtract 9 to get negative 1. Also, we never ever add unlike terms. So for instance, we cannot do 5 plus 3 is 8xy minus 9. Okay, we can only collect or group like terms. Let me just give you another example of this because it's a really important concept. Say for instance we have 3 triangles and we add together 5 circles and we subtract $9. This is the same as saying 3 triangles plus 5 circles. This is a circle and not a 50. Subtract 9. Okay, so let's just have a quick look at the next box, like terms. And I want you to pause the video and see how we have combined or grouped the like terms. Hopefully you've done that now. So what we've done is that we've brought the w's together to go here, and we've brought the numbers together to go here. And we've said that 4w plus 2w is 6w, and 3 minus 1 is 2. I'm going to do a similar problem down below, and I would like you to collect the like terms. Let's do triangle, 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 plus square, 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 and then we're going to add on 17. Pause the video and see if you can simplify this. Okay, so we have 1, 2, 3, 4 triangles, plus 3 squares, plus 17. Okay, so let's have a look at some problems. Let's do 4x plus 2x plus 3x, 3x plus 2x plus 4x, and I would like you to collect like terms for me. Okay, so all these are like terms, so we can add 4 plus 2, which is 6, plus 3, which is 9x. Here we can do the same. 3 plus 2 is 5, plus the 4 is 9x. Let's try something slightly different. Let's do 2y plus 4x plus 3y minus 2x. And let's do 10y minus x plus y, negative 2y plus 4x. Okay, now these are slightly different. Pause the video and see if you can simplify these. Okay, so hopefully you've done that now. I'm going to do something to make it slightly easier. I'm going to circle the like terms in green. And sometimes when you're doing these problems, it helps to have a pen with a different color. So let's go red, and I'm going to circle the x values. Now this is very important. There's a lot of confusion where the sign is associated to. The sign is associated with the number to the right. So we haven't put a sign in here. That is the same as positive. This positive here is associated with the term to the right, which is the 4x. This positive sign here is associated with the term to the right, which is the 3x, and so on. That is a very important misconception which many students make. So let's collect the like terms together then. We've got 2y plus 3y, and then we've got 4x negative 2x. So if we add the y's together, we get 5y, and if we do the subtraction, 4x minus 2x is 2x. We are left with this. Okay, let's do 4. We're going to circle the like terms. And we missed out the y here. Okay, so we've got 10y plus y negative 2y. Then we've got negative x plus 4x. If we add the y's together, we've got 10y plus another y is 11y. Subtract 2y, and then we're left with 9y. If we add the x's together, we get 4x minus x is 3x. Okay, so let's have a look at doing some problems. Here we have standards, and the next section we have accelerating. I would start at standards and then work your way to accelerating. Pause the video, please. Okay, so hopefully you've done that now, and I'm going to put the answers up, and I would like you to mark your work. Okay, so let's move on to something slightly different now. Now, there's a subtle difference here in that we have letters and numbers. We have letters and numbers. Now, I'm going to do a slightly different way of explaining this. So we have V's, we have U's, and we have numbers. So we've got V's, we've got U's, and we have numbers. Okay, so I would like you to pause the video and sort these variables out for me, please. Okay, so just looking at the variables, we have negative 3v, negative 3v, we've got negative 9u, positive 9u, and the numbers, we have negative 1 and negative 8. So we can circle them if you like as before. Being careful to circle the sign as well. Okay, so if we add those together, negative 3v plus negative 3v is negative 6v. We've got negative 9u plus a negative 9u. That gives 0. Then we are left with negative 8, negative 1 is negative 9. We'll just simply write that in negative 6v plus 0u, negative 9. And we can leave out 0u just to get negative 6v minus 9. So let's just do that in a slightly different way. Let's just do that in a slightly different way. Let's write them down. So we've got negative 3v, negative 3v. We've got negative 9u plus negative plus 9u. And we've got negative 1, negative 8. So here we're just left with negative 6v. Here we are left with 0u. And here we are left with negative 9, which is the same as negative 6v, negative 9. Okay, so see if you can pause the video and do B, C, and D. Okay, so hopefully you've done that now. Let's circle the like terms, the H's. Let's circle the N's. And let's circle the numbers. So let's write down the H's first. We've got negative 8h, negative 10h. We have negative 5n, negative 5n. And then finally we have negative 8, negative 3. So negative 8h, negative 10h is negative 18h. We've got negative 5n is negative 10n. And then we've got negative 8, negative 3, which is negative 11. And that's your final answer. A really important misconception is that negative 3 is positive 6. That's only true if you're multiplying. So negative 3 multiplied by negative 3 is positive 9. Okay? A negative multiplied by a negative only gives a positive when you're multiplying. Now, if we have something like this, negative 3, negative 3, that is a multiplication. That is a multiplication because we've got negative 3. That's a multiplication. So we need to rewrite that now. It's negative 3. Negative times a negative is a positive. And we just get 0. Okay, let's do the remaining questions. So we've got 2x, negative 10x. We've got 6r, negative 4r. Then we are left with negative 1, positive 8. So let's write down the x's. So we've got 2x, negative 10x. We've got positive 6r, negative 4r. And then we've got negative 1, positive 8. If we've got $2 in the bank and we subtract $10, we've got negative $8. If we have $6 in the bank and we subtract $4, we have $2. Then if we are already negative in the bank, we've got negative $1, and we put in $8, we have positive $7. So the dollar and the bank is just an analogy to deal with the coefficients. It's just an analogy. And then finally, the last one, negative 3f, negative f. We've got 4t plus 5t, and then we are left with, okay, so we've got negative 3f, negative f. We've got negative 4t, positive 5t. Then we have got positive 3, negative 2. So we've got negative 4f. We have positive t, and we can write the 1. It's not wrong to write the 1, but it's more elegant to leave it out. And then we've got 3 minus 2, which is just 1. Okay, so pause the video and make sure that you understand every step, and then have a go doing these questions. And pause the video. Okay, so hopefully you've done these questions now. Please make sure you mark your work. Pause the video and mark your work. And let's have a look at some more examples now. Let's just take a closer look at negative 3v squared. This is the same as negative 3 times v times v. Now, these have little powers on top. Power of 1. So we've got negative 3. Remember, if things are next door to each other in maths, that means they're multiplied. Now, instead of counting the powers as the coefficient, we count them as powers and we add them. So we've got negative 3v1 plus 1, which is negative v squared. Okay, now a really important concept is that v and v squared and v cubed and v to the 4 are not like terms. Just because they are v, they're different. They're different. Now, there's a little bit of confusion because 1v and 2v and 3v and 4v are like terms. We can simplify these. V plus 2v plus 3v plus 4v, 4, 5, 6, 7, 8, 9 is 10v. We can collect like terms here, but we cannot collect like terms here. They are different. They're different. And we can think of this as the following. So v could be just a length. V squared creates an area. V cubed, well, we've got v squared, creates another length. V, V, V. So we've got just a single v, we've got v squared, then we've got v cubed, and then let's get really complicated, and we can say that v to the power of 4 is v squared plus v in a different time. So that is the fourth dimension. So we've got v squared cubed there, and we're saying that this block in a different time is v to the 4. Okay, so I hope I didn't go off on too much of a tangent there, but I think it's important to distinguish that powers and coefficients are different. They're different. So based on that little example, I would like you to simplify these. 2v plus 4v minus v minus 2v, and then 2v squared plus 4v cubed plus v squared plus v cubed. Pause the video and have a go at simplifying these. Okay, so hopefully you've done that now. So we've got 2v plus 4v is 6v, minus v is 5v, minus 2v is 3v. Here, let's write the like terms together. You can add that to get 3v squared. You can add that to get 5v cubed. Okay, so pause the video and see if you can do A and B. Okay, so hopefully you've done A and B. So let's circle the like terms. So we've got v squared. v squared. We've got v and v, and then we've got numbers. So let's write those down then. We've got negative 3v squared, negative 3v squared. Then we have negative 9v, positive 9v, and then for numbers we've got negative 1, negative 8. So we've got negative v squared, negative v squared. If we borrow $3 from the bank and then borrow another $3, we owe $6. But instead of dollars, we're dealing in v squared. If we owe the bank $9 and we pay in $9, we are left with $0. And if we borrow $1 from the bank and then we borrow another $8, we owe the bank $9. So we are left with negative 6v squared, negative 9. Okay, so hopefully you've done the second one. So I'm going to circle the like terms. Okay, so let's write the like terms together. So we've got negative 8u squared, negative 10u squared. We've got negative 5u, negative 5u. And then we've got the numbers, negative 8, negative 3. Okay, so I'm just going to write the answers down below. Negative 18u squared, negative 10u, and then negative 8, 9, 10, 11. So mark your work, please. Okay, so have a go at doing these. Pause the video and then mark your work. So hopefully you've done these. So I'm going to say mark your work and give yourself an answer, a mark out of 9. And hopefully you can now simplify algebraic expressions.